So to understand why explainable machine learning models are truly powerful, we need to compare them. And we'll compare them to the traditional ones, right? So traditional machine learning models, right? And then what we feel is the next generation of all machine learning classifications, the explainable ones. Explainable machine learning models, right? Comparing the two, there's many different ways to do that, but let's start with the very beginning, right? Let's start with how they all essentially start, with the data set. When creating traditional machine learning models, companies which create them usually, pick millions and millions of files, and then they sort them into buckets of good and bad, right? So you get something like this, a large data set. It's roughly split into half, right? Have some goodware, you have some malware. You're trying to train the machine learning model to discern one from another, right? And that kind of defines what the ultimate outcome of a traditional machine learning model is going to be, this classification of good versus bad. But when you try to create an explainable machine learning model, you're really talking about lower numbers, hundreds of thousands, right, of samples which are better labeled. So you're not really labeling them as good and bad, though both are required. You're really creating smaller clusters of different threat types. So you're creating clusters of, let's say, ransomware, rats, keyloggers, right, et cetera, right? So smaller but well-defined threat types grouped into clusters of data. The reason why we want to do this is because the end result of the explainable machine learning model needs to be a classification which is capable of discerning not only good from bad, but also telling you if something is ransomware, if something is a remote administration tool, keylogger, and so on. So this is a lot more difficult than doing just good from bad, because proper labeling is time-consuming. You need to have analysts who really understand these threat types, and they can create these data sets in a way that machine learning can separate not only good from bad, but one threat type from another, right? So that's the first bit. So the second bit are the features. So what kind of features do traditional machine learning models use, right? They're really looking at it from, yet again, standpoint of there's millions of them, right? And that's where the explainability is really lost. So what traditional machine learning models are trying to do, they're trying to quantify the file by looking at different properties of the file. They're looking at the header information, right? They're looking at the functions, and they're trying to convert all of that into sets of real numbers. So something from 0 to 1, right? A feature would be, for example, right, would be the number of strings within a file, right? The value of a certain header field, the sum of all of the letters of a function that the file imports. So everything which used to be human recognizable converted down to a number and used as a feature. And yet again, millions and millions of these features, because traditional machine learning models use these features to better discern good from bad. So any one of these features can provide, that context of, well, if a feature is only found in goodware, for example, then that feature, when seen in a file, will tell the model, well, this is most likely good. The same goes for bad, right? So these traditional machine learning models are easy to overfit in any of these directions based on the features which are solely found within that bucket. And that to us felt really, really wrong, because converting human experience into a set of numbers is not how humans interpret information. So when we created our own features, we started from a similar standpoint, but we said, okay, can we translate these features into something a person can understand? So that's how we got to the indicators. Indicators are textual descriptions of intent. They are features for our machine learning model, but they're not ones and zeros, really. They are textual descriptions. So quite literally, the feature would be downloads a file. Downloads a file. Executes a file, right? Or does anything with the file. And all the other features that we have. So in this term, we're not talking about millions of features. We're talking about tens of thousands of human-readable indicators that a person can read and understand that that is the ultimate behavior of a file, right? So going away from unexplainable and moving towards explainable. So since these are only the features which matter and the humans can interpret them, training the models to detect malicious content and group them into specific types is much easier. And not only it's easier, it's better for the end user because the outcome for these two classification models is very different. So here, we're really looking at, the outcome, is this good or bad? And what is the likelihood of this being actually bad? So you would get something like this, malware, 80%, right? That is the output of a traditional machine learning model. For us, that is a lot different. For us, since we started with a data set which is properly labeled, we can say something is ransomware. And that's it. That's the classification. When you're looking at the file, you know not only that it is malicious, you know the type. And the type is really important because it allows the defenders to plan how to defend, right? There is a completely different strategy to defend the environment from ransomware versus a keylogger versus a backdoor. And that is why this is really important. This is actionable, so you know what your next step is. This requires additional verification. So an analyst, when he sees something is 80% likely to be malicious, has to go to the next steps. And the next steps in these particular situations are, well, either dynamic or static analysis. And that ultimately provides the analyst with the idea of, well, what type of malware am I dealing with? What damage it's going to do? How does it spread? And everything a defender needs to know. So the only way you can get from a classification to an action is through an external tool. While with the explainable machine learning models, that's not the case. And so the action an analyst can take at this point, right, is not to spend time analyzing the data in third-party tools, doing dynamic, doing static analysis. All of that has happened while we were doing the classification. So the next step for an analyst here is action. It's moving away from the concept of now I have a detection to how do I protect my environment? And you already know from what type of a threat you need to protect your environment from. So the action can be, looking at all of the endpoints which contain this particular piece of threat, closing down the network, re-imaging systems. All of that are concrete actions which end up protecting the environment. And there's less time spent analyzing what I'm supposed to be protecting against versus actually doing and protecting the environment.